Swayam Prabha. Digital India. Educated India.
In this lecture, lecture 4, as I told you in the previous lecture that we will discuss on reinforcement bars, which we did not discuss at all in the previous lecture. We were discussing mostly on rolled steel. Rolled steel is used independently, it can take tension, compression, etc., and it can itself act as a structural member. Coming to this particular lecture where we will discuss reinforcement bars, corrosion and light gauge steel. Now, reinforcement bars, as I discussed, it will be embedded within concrete. Next is corrosion, which we will try to expose the defect or the drawback of steel or iron, and we will try how we can actually take care of corrosion, because steel is so versatile in its use, but it is having that property of being corroded, and that is a defect, and if we can overcome that defect, we can actually make use of steel to its best way, in its best way. And I will try to expose you to another item, that is light gauge steel. This is now into our CPWD specification also. This is a not exactly 100% a steel structure, but light gauge steel can be used as a structural member for say 2 to 3 story high, maximum 4 story high, and it is a very cost effective way of construction. So, I will just expose you to light gauge steel maybe in one slide, and we will try to finish the ferrous metals. So, coming to the steel reinforcement bars, which you many a time see on construction sites, rods, bars which are mild steel having less of carbon. They are usually starting from say 2 millimeter, 3 millimeter, 6 millimeter, 8 millimeter, 10 millimeter, 12 millimeter, 16 millimeter, 20 millimeter, 24 millimeter, and up to 50 millimeter you will get such bars. So, in your further classes you will go for understand the calculation part. Depending on the area of steel required to take the tensile load of any structure, you have to first estimate the area of steel required and distribute it into the number of bars required. So, each bar is a circular in diameter, so you know the area of each bar. So, you have to divide it with the dimension of the bar of a specific diameter and find out number of rods that will be required. And you have seen in my previous lecture on concrete that a dense network of reinforcement is there before any casting of concrete takes place. So, these we are referring actually to these bars. What is the advantage? These bars go embedded inside the concrete. You won't see in any structure that a mild steel bar is taking the entire load. Rather, you can see an angle section, rolled section taking load, or a tubular circular section taking load. But these are reinforcement bars. They go into concrete for reinforcement. So, these are usually used for building purposes, general building purposes, and you can see the tensile strength, it is having between 215 to 250 Newton per millimeter square. And to be precise, there are grade 1, grade 2, different types of mild steel bars. So, as you can understand, mild steel bars are plain on the cross section. If you see the picture carefully, it is having a smooth surface on its longer face. Unlike the bars which you see in this picture, the new picture, here you see ribs or lugs. These are called cold twisted deformed bars or high yield strength deformed bars. These are mechanically further strengthened by cold working. That is, no crystallization pattern changes inside like hot rolling. So, you are twisting, you can draw it, you can stretch it. Those will give you this kind of bars. These are high yield strength deformed bars, and it has ribs on top. If it is twisted, it is taut steel bar. So, what is happening? The bars are having twists. What does it help in? What is the difference between the upper picture and the lower picture? When it gets embedded in concrete, it is very difficult to move this ribbed bar instead than that of a mild steel bar. You cannot pull it in both the cases, but the bonding strength between this bar and the concrete will be higher than that of the mild steel bar and the concrete. So, this is more preferred, and you see the tensile strength is for this cold twisted deformed bar is similar. What you are achieving? You are achieving higher bond strength between bonding of concrete with steel, and this can reduce the use of steel by a good percentage. Another point you see which is separately written that was heat treatment. So, here you see thermomechanically treated bars. Thermo means temperature. So, you are allowing heating to change the property, the mechanical property of the bar. What is happening here? Short intensive cooling when it is dipped in water and then surface layer gets hardened. So, as I was talking of the different types of steel through the time temperature transformation, here you see I have mentioned two. The outer layer which gets immediately cooled gets a crystalline pattern changed, whereas the inner core remains in its original form, that is the pearlite core. So, outside which was heated, thermally treated and intensive cooling was done by dipping it in water, what has happened? The crystallization pattern of the outer layer has changed to martensite steel. Inside is still hot. It is still changing the crystallization pattern of this martensite steel, and this gradually cools in the atmosphere. Outer remains martensite, inner remains pearlite, exhibiting different kind of property. It gives higher strength and ductility, and also high temperature resistant up to 500 degrees centigrade. Why we mention this here? Because even if it is embedded in concrete, if it is subjected to fire, if the structure is subjected to fire, these bars, if the heat reaches, it will get D-shaped and the structure will crumble. So, having higher resistance to temperature is to be noted and is very important. These thermally treated bars or the TMT bars are weldable, and at the point of welding it does not have a loss of strength. We can get high strength starting from 450 Newton per millimeter square to up to 550 Newton per millimeter square, and around 40% of use of steel can be reduced and hence recommended for high rise structures. As I have already told in my first lecture of this module, that steel is quite heavy. 7.8 is its density, gram per cc. So, just recommending lot of steel structure is recommending lot of weight to the structure. So, the self weight increases. If you go for such kind of thermomechanically treated bars, 40% of the steel use will be reduced. Hence, it is recommended for high rise structures. Further, you get the advantage of high temperature resistance and obviously high tensile strength. Another item, another rebar or reinforcement bar, thermomechanically treated high corrosion resistant bar. This is again some chemical changes happen within the TMT bar. The same thermomechanically treated bar has chemical changes inside it, and that gives it the added advantage of having higher thermal resistance of up to 600 degrees centigrade along with lesser corrosion. So, these members will be further recommended for high rise structures. Obviously, the strength wise it will be similar to 30 MT bars, and they are bendable without cracking. So, we see the reinforcement bars are of different kinds, not only the mild steel bars. We have the mild steel bars for regular use, but with the changes, with the advancement, cold twisted deformed bars or the high yield strength deformed bars has come to the market, having higher bond strength, higher tensile strength, lesser amount of use, hence making the whole system cheaper. Further, we have the thermomechanically treated bars, which have a outer layer of a different type of steel, inner of a different type of steel done through or achieved through heat treatment, having higher resistance to temperature, and TMT HCR bars having lesser chances of corrosion. So, all these types of bars go embedded in concrete, unlike the rolled sections. So, what is the advantage of these bars? The advantage of these bars are they are not getting exposed to the atmosphere directly, and that helps to resist or keep it safe or keep it in an environment away from the atmosphere and thus prevent corrosion. So, we open this slide which is titled as corrosion, which is a very common phenomena which all of you know. I am 100% sure you all know rust. We see iron items and we see, oh, it's rusted. What is that? It is the oxidation that happens to the body in presence of the oxygen in the atmosphere. We cannot take out oxygen from the atmosphere. So, these rebars which are embedded in concrete has the added advantage of not being exposed to oxygen. What helps in rusting? Oxygen, water and carbon dioxide. So, this ferric rust or ferric oxide forms in stages. It degrades the iron. It is seen as a red brown compound. Our concern is we have to stop this oxidation process because the metal oxide has lower energy or lower strength than that of the metal. So, it is weak, otherwise it would not have concerned us. Let it rust. If it has same strength, why do we bother? We bother because its strength gets reduced, it increases in volume, the oxide is increasing in volume, and you note the point in red, corrosion is a surface phenomena. It is happening only on the top of the item, the topmost layer which is exposed to atmosphere. It increases in volume and obviously it sheds off. It comes out from the mother surface. And then what happens? If it would have stayed there, fine, it would have rusted and stayed there as a coating. No, it comes out because it increases in volume and exposes the inside. That is the inside or the next layer, which again experiences rusting because it is exposed to atmosphere and that particular area gets weaker and weaker along with the entire structure, entire material. Because as our atmosphere has water also, water vapor also. So, oxygen, carbon dioxide, water, all three with this iron through the different chemical reactions stages moves and goes through to form this rust, flakes out, exposes the outer layer, inner layer, and further rusting happens. So, we need to take care of it. So, what can we do? We can prevent it from we can modify the surface or change the environment as a possible remedy. Let us see some pictures. You see the first picture here. You see the layer is flaking off, which I have told you just now. See, these are the flakes, that is the upper layer is coming out and exposing the inner layer. So, in the next stage the inner layer will get corroded or rusted. You see here a pipe has been painted, inner is iron which is getting rusted by entry of water vapor or leakage. It may be a water carrying pipe, it may have internal leakage wherefrom it is getting water as well as air as well as carbon dioxide, and the rusting has happened and it has pushed, because it has increased in volume, pushed the layer of paint and the paint layer has come out, and with that paint layer is adhered the iron flake, iron oxide flake. So, that is coming out. You see the steel structure is completely rusted on prolonged exposure to atmosphere. But what we see different is in these two pictures on top. These are rods embedded inside concrete. These are rods embedded inside concrete. Concrete had, if you remember, a layer or a clear cover. So, the rods were kept and the concrete was supposed to cover it. So, this was at least 25 millimeter. You can go back to that module. That was called clear cover. So, just think of the pressure this rusted iron creates, that this 25 millimeter of concrete can come out. So, it is not just the paint layer that is coming out, but the 25 millimeter of concrete layer completely that has come out just by pressure created by the increase in volume of the rusted iron. So, you can understand this rusting has happened in absence of atmosphere, but the trapped in air, trapped in moisture has led to such corrosion. There may be fine cracks which were not visible, through which air has passed through, and this has taken a long time, a gradual process, but it has ruined the concrete. So, corrosion has a far reaching effect onto building, even if the reinforcement, even if the steel or iron is embedded. So, we have to be very careful on that. So, we can protect by coating. You can see the picture of a roofing where it is coated. Coating with maybe paint, red oxide is the bare minimum, with coal tar, that is jet black, but if you paint you are rid of corrosion, rid of rusting. You can have oil modified alkyds, epoxy esters, vinyls, acrylic polymers. It is a cladding or a dress you are putting a dress on top of the iron member. You can have plating, electroplating with nickel, tin or chromium, mechanical plating with metal powder, and the other is galvanizing. You all know galvanizing is usually involving zinc galvanization, where zinc in its as a molten metal is coated on top of the iron object, and zinc actually reacts with the atmosphere. Zinc has a very slow reaction with the environment and hence it protects the mother material. So, you are doing a metal plating on top of a metal to prevent it from its oxidation process. Anodic coating is another where aluminum oxide prevents corrosion. The surface is subjected to chemical or electrochemical process. And you have already noted the alloy formation. You can have stainless steel, copper nickel, high temperature alloys made of steel, made with one of the components as steel or the major component as steel, and you can actually go for corrosion resistance. However, we find coating as a very easy, plating as a very easy process, alloy formation etc. is practiced but not much in the building industry. We also need to know the temporary methods. As we had talked extensively of rebars, if you see or visit a site, you will see lots of reinforcements lying here and there, means clustered together. So, how to maintain those? Say they will be used in 1 month time. So, will they be exposed to the weather and let that they be corroded, or should there be some temporary methods to prevent it from corrosion? First important point is to keep them raised from the ground. You can just put brick as a support below at a interval and raise the entire steel bars and keep it free from the ground, so that the water is not coming in contact. Then you brush the exposed parts, whatever you can see, with a cement slurry. Why cement slurry? Because later on it will be embedded in concrete, where cement will be one of the components. So, it does not need to be taken out, and you are only putting on the exposed part. You are not opening and individually painting it with cement slurry. You are putting or dabbing cement slurry on top of it. You can also coat it with engine oil on top, on the surface, exposed surface, to prevent corrosion. But when you use it, you must wipe it off with sandpaper. Otherwise, this engine oil will prevent bonding with the concrete. So, these are the two things which can be done. One is painting with cement slurry, other is coating with engine oil, but the first one is preferred. You have also seen in our rolled sections, we had seen the angle sections. Now, if it is advisable to keep such sections or place such sections on structures in this direction, so that the water accumulation does not happen in these portions. Now, water is not supposed to get accumulated because you are having a slope. But yes, some dust etc. particles may come here which can retain the moisture or the water and allow rusting here. So, if you use such T sections in this direction, you will always get an advantage of the water getting drained out. So, a clear instruction should be that these sections should be placed in such a way that water accumulation is not possible. Even dust accumulation is to be avoided. We have to be very particular on this point of corrosion. If we can actually check the corrosion, then actually we can do a good justice or use of steel in the building industry. Now coming to a brief on light gauge steel. BMTPC, which I have already discussed in some previous lecture in precast items, they have now introduced this item in our central public works department specification. So, this light gauge steel is using steel structure instead of our regular concrete and making the structure light in weight and cheap. These are nothing but C sections, that is C sections means channel sections which has different slots on its web, that is, this is the web part. It will have slots on its web at different levels, that is floor level, sill level, lintel level, where it can be bolted with its perpendicular member, horizontal member, perpendicular member to create a framework, as you can see in the picture. And just see the dimension. It is of 0.55 millimeter to 1.55 millimeter thickness, pre-treated factory finished hot dipped galvanized iron high tensile steel sheet. It is made from that. So, these are actually made from between 0.5 to 1.5 millimeter thin sheet. Gauge is a measure of thickness. So, these are folded in such she shape and they are having, you see, notches, dimplings, slots, service holes etc., all pre-designed. These slots will bear the joints and will create the framework onto which the cladding material or the covering material, it may be precast panels, which will be bolted on top of it. So, the entire assembly will be light in weight and it will be a fast process of construction, and these special screws will take in the loads whichever it will be experiencing. These slots will be all computerized while it is formed, because each of these slots will have the galvanization to prevent rusting, and these are to be maintained for as a structural member for a considerable period of time. So, rusting cannot be afforded. So, everything is pre-planned, pre-designed, the framework is made of this light gauge steel. So, with this this is a new or advancement of steel structures, but these are practiced in countries abroad, but in our country context, yes, it has started, government has started building such, say Anganbari projects etc. are made of light gauge steel structures. Some are there in Orissa also, particularly Bhubaneswar. Yes, organizations are making, but we do not have a light gauge steel production factory. So, we have to bring in from abroad. So, we have to import it from outside, hence cost effective, it is not that cost effective, but yes, if we actually start building with this, we can actually get cheaper lightweight structures. With this, we finish the ferrous part, and in my last lecture of this particular module, we will cover the non-ferrous metals. Thank you.